Hello all, this is Fahim again, and this is my week 7 tech seminar video. And this week I have studied about quantum computers, and I will be sharing a bit about what I have understood because I have not understood too much because it is a very complicated and confusing field. When I first started watching, I didn't understand much, but I referred a few other resources to uh, try to understand it, and I will be sharing what I have understood. So first let's talk about normal computers and how quantum computers differ from them. Normal computers, as everyone knows, make use of bits, zeros and ones to transfer information. They're very simple because 0 means no electricity and 1 means there's electricity there. That's how computers communicate. But the issue that is coming up is that our components, our computer components, the chips and the stuff that make up our computers are reaching a physical limit because they are so small that their components are almost the size of atoms. And when things come into this such a small scale, the laws of physics change. That is, the laws of physics starts to act in very unexpected ways. This is because quantum physics comes into play when the size is such a small such a small size, right? So if this happens and our components are so small, things like quantum tunneling can happen. Quantum tunneling is when you try to block an electron, that is, you say to block an electron, the electron can still pass through using because of this phenomena known as quantum tunneling. So when this happens, bits that are supposed to be ones might end up becoming, supposed to be zeros might end up becoming ones because their electricity passes through even though you have blocked it. So now you understand that we are reaching a physical limit to how small we can make our chips. So we need a better option. So what researchers did is that they tried to think about how we can use this phenomena of quantum physics to create better computers, right? So they created or are in the process of creating something known as quantum computers, and they make use of quantum computing to do calculations that is impossible for normal computers to do. This is because quantum computers make use of not bits but qubits or quantum bits, and quantum bits are not made up of electrons like bits are. They're made up of photons and other stuff. And what are qubits actually? Qubits are qubits can be either in the state of on or off at the same time. Now this can sound confusing. So what this means is the qubits can be 0 and 1 at the same time, but the thing is they can be in a proportion of either 0 or 1. So that means just one, we can do multiple calculations with just the same qubits. So what happens is, in the case of solving a maze, right, normal computers would go through each of the routes and try to solve it and find out the way in which they'll be successful. That's how normal computers work. But what quantum computers can do is they can try all of the routes at the same time, because the qubits are in something known as a superposition. That means I have both 0 and 1 at the same time. And this can be very powerful because calculations that take a long time can be done very fast using these qubits. And there's a few things that we have to know about qubits, like entanglement. That is, qubits can become related to each other or entangled with each other, so that you can infer the properties of the other qubit when you observe one qubit, even if they are very far apart. And the most important, currently quantum computers are not very useful, they are still in development. they're not useful because their inputs are first of all in superposition, right? I said superposition, that means they're either in 0 or 1 states. So what happens is their output is also in the same superposition. So when we view that, it is we cannot know what is the actual output that is going to come out. So this means that quantum computers are currently not useful. But one field that is very likely to be affected by quantum computers is the field of cryptography. Our privacy is a big concern when because of quantum computers. This is because currently the most widespread form of encryption is a private public key encryption that makes use of prime numbers. So how this works is, the sender has two prime numbers and they multiply the prime numbers together to get another number, and this number is used to encrypt our message and is sent out to the receiver, right? And the receiver will have access to the number and they can decrypt the message. So this is very hard for normal computers to decrypt, because this would take a long time, like years and years, for computers to successfully crack this. But when quantum computers come into play, something that took thousands of years for computers to do will take quantum computers just like a few minutes or at most hours to do. So this poses a big risk in terms of the security field of things. So right now there is a big rush to make there's a race going on one side to make the quantum computers a reality, and on the other side people are scrambling to make our encryption more encryption resistant to quantum computers. So that's what I have learned about quantum computers today. I hope you learned something. Thank you.